Tonight, let's take a slow walk under the night sky. Not the dramatic, movie-style sky full of alarms and exploding planets, just the real one. Dark, wide, patient. The kind of sky that makes city noise feel far away, even if you're still in the city. Because the truth is, above the calm, there is motion. Tiny grains of rock, frozen bodies older than oceans, leftovers from the solar system's earliest days. Most of them pass by without meaningfully touching our lives. Many of them burn up so high above us that the world below never notices. And yet, across deep time, a small number of these visitors have done something unforgettable. They've lit the sky like daylight. They've shattered windows. They've scarred the ground. In rare moments, they've changed the course of life on Earth. This is the story of meteors and meteorites, asteroids and comets, and the ways they've touched our planet. From gentle nighttime streaks to ancient global turning points. Let the pace stay slow. Let the images come and go. The sky can hold big ideas without rushing. Chapter 1: Names for Falling Stars. Before the stories begin, it helps to give the sky's visitors their proper names, simple names, clear names. Meteoroid, the traveler in space. A meteoroid is a small piece of rock or metal traveling through space. Some are the size of sand grains. Some are the size of pebbles. A few are the size of cars or even houses. Many meteoroids are fragments, chips knocked off larger asteroids by collisions long ago. Others are crumbs left behind by comets, scattered along their paths like a trail of invisible glitter. Meteor, the light in the sky. When a meteoroid enters Earth's atmosphere and starts to glow, the glowing streak is called a meteor. That shooting star you've seen, quick, clean, almost delicate, was not a star at all. It was a small object meeting the air at tremendous speed, heating and shedding material, turning motion into light. Meteorite, the piece that reaches the ground. If any part of that object survives the journey and lands on Earth, the material on the ground is called a meteorite. Meteorites can be small enough to fit in your palm or large enough to need machinery to move. Some look like dark stones with a thin melted crust. Some are metallic, heavy for their size, with patterns inside that hint at slow cooling in ancient space. 3 names, 1 journey. Meteoroid in space, meteor in the air, meteorite on the ground. And now, with the names in place, we can let the sky start talking. Chapter 2: Comets, the slow lanterns of the solar system. Comets feel like myths with a physics degree. They show up with little warning, grow a bright head, and stretch a luminous tail across the night. Then they fade again, slipping back into darkness for years, centuries, sometimes longer than civilizations last. What a comet really is. A comet is often described as a mix of ice, dust, and rocky material. Not a clean ice cube, more like a frozen archive. Water ice, carbon-based ices, dust grains, and bits of rock, all packed together since the solar system was young, why the tail always points away. As a comet approaches the sun, sunlight warms it. Frozen material begins to escape into space as gas, carrying dust with it. This creates a fuzzy atmosphere around the comet's core. Then the sun pushes. Sunlight and the solar wind act like an invisible stream, sweeping gas and dust away, forming tails that generally point away from the sun, like a windblown veil. A comet's tail can look like it's trailing behind as the comet moves, yet it's really responding to the sun, not to the comet's direction of travel. Where comets come from. Many comets come from deep reservoirs far beyond the planets. A region beyond Neptune filled with icy bodies, an even more distant shell of objects surrounding the solar system in every direction. Most of the time, these objects remain quiet and remote, but occasionally, gravity nudges one inward, an accidental invitation to the inner solar system. And when a comet visits, it doesn't just bring beauty, it can also bring debris. Because comets shed material, leaving streams of particles behind. When Earth passes through those streams, the sky fills with meteors, meteor showers, predictable, seasonal, often gentle. A reminder that the solar system is not empty space. It's a place with weather made of dust. Chapter 3. The Atmosphere, Earth's Nighttime Shield. Earth has a guardian most people rarely think about: air. The atmosphere looks invisible, feels soft, and yields to every breath. But to a fast-moving meteoroid, the atmosphere is not soft at all. It's a wall that thickens quickly, the soft barrier that hits like stone. When an object enters the atmosphere at extreme speed, air can't move out of the way fast enough. The object compresses the air in front of it, heating the air and itself. This is why meteors glow. The light comes from hot, excited gases and from material vaporizing away. For small meteoroids, grain-sized to pebble-sized, this heating usually ends the story high above us. They burn out. They become dust. Fireballs and airbursts. Larger objects can produce fireballs, brilliant meteors, bright enough to cast shadows. Sometimes they break apart in the air, releasing a burst of energy. This is called an airburst. An airburst can be loud. It can create shock waves. It can rattle buildings, yet it might leave little or nothing on the ground because most of the mass is destroyed or scattered. This matters because many damaging events in recent history were not crater-forming impacts. They were atmospheric explosions. A reminder that Earth's shield is powerful, but not perfect. Chapter 4. A Morning in Russia, 1908. The Tunguska event. Now the story steps into the 20th century. Imagine a remote region of Siberia, forests that stretch without end, rivers that carve through wilderness, small settlements scattered far apart. On a summer morning in 1908, something arrived. People reported a bright object moving across the sky. Then a tremendous explosion, heat, a shock wave. In some places, people were thrown to the ground. Far from the epicenter, windows shattered. The sky glowed strangely at night for days afterward in parts of Europe and Asia, bright enough, some said, to read outdoors after midnight. When investigators later reached the area, they found no giant crater. But they found something else. A forest laid down, trees flattened outward in a vast pattern, like matchsticks pressed by an invisible hand, covering an area large enough to feel unreal. What likely happened? The best scientific explanation is that a cosmic object, probably a stony asteroid fragment, possibly a comet fragment, entered the atmosphere and exploded in the air. Instead of striking the ground as a single body, it disintegrated and released energy above the surface, creating a massive blast wave. Tunguska became a lesson. You don't always need a crater for a cosmic event to be serious. And it became a warning written in fallen trees. Earth lives in a shooting gallery, even if most shots miss. Chapter 5, Chelyabinsk, 2013. The day, the sky punched back. Fast forward to 2013. This time, the location is also Russia, but the setting is different. A modern city with traffic, apartment buildings, schools, dashboards with cameras. On a winter morning, a bright fireball crosses the sky. It grows brighter, too bright to stare at. It flares. It breaks apart. Then, minutes later, the shockwave arrives. Windows burst inward. Doors slam. Walls tremble. Thousands of people are injured, mostly by flying glass. The injuries are real, but the event is also strangely ordinary in its aftermath. People sweep, tape windows, share videos, and go back to work. Unquote. The strange delay. Chelyabinsk taught many people something counterintuitive. The flash comes first. The boom comes later. Light reaches you quickly. The shock wave travels slower, so the sky can explode, and the sound arrives afterward, like delayed thunder. A modern lesson. The object was not gigantic by cosmic standards. It was not a dinosaur killer. It did not end a civilization. But it was enough to injure many people in a populated area. Chelyabinsk was a reminder that mid-sized events matter because Earth has cities now, and it showed the value of something humans are finally doing well: watching the sky. Chapter 6, Meteorites on the Ground, Messages You Can Hold. Not every story is explosive. Sometimes the sky delivers a quiet artifact. A stone lands in a field. A farmer finds an unusually heavy rock. A scientist cuts it open and discovers metal grains, chondrules, tiny ancient spheres, structures that haven't changed since before Earth had oceans. Meteorites are time capsules. What meteorites tell us? Meteorites can contain evidence of early solar system processes, material older than Earth's crust, chemical clues about how planets formed, sometimes even organic compounds, ingredients of chemistry, not proof of life, but still intriguing. There is something soothing about this. A piece of space can land here, and instead of ending the world, it becomes a museum specimen, a reminder that not all cosmic contact is catastrophe. Chapter 7, the biggest chapter. Chicxulub, and deep time change. Now we move into deep history, not the history of kings and empires, the history of continents, oceans, and evolving life. About 66 million years ago, an asteroid struck what is now the Yucatan region. The impact formed a vast crater today, largely hidden under layers of rock and sea, and it released energy on a scale beyond anything in human experience. This event is strongly linked to a mass extinction that included the non-avian dinosaurs. What an impact can do to a planet. A large impact can trigger global fires from intense heating and re-entering debris, mega tsunamis in oceans, dust and aerosols thrown high into the atmosphere, reduced sunlight and disrupted climate, food chain collapse, especially for organisms dependent on sunlight-driven ecosystems. It's not just the moment of collision. It's what happens after the weeks, months, and years of atmospheric effects. A quiet perspective. This can sound terrifying, and in a sense, it should. Nature has teeth. But there's another way to see it. Life endured. The world did not end. It changed. New niches opened. Mammals diversified. Over immense time, eventually, a species appeared that could look back and understand what happened. There's a kind of cosmic irony in that gentle, not cruel. The same universe that can erase a dominant species can also give rise to minds that learn the story. Chapter 8: Comets in Human History. Fear, Wonder, and Misunderstanding. For most of human existence, people did not know what comets were. A bright comet could appear suddenly and hang in the sky for days or weeks. Without scientific context, it was natural to read meaning into it. Comets became symbols of change, of warning, of fate, of divine messages, depending on the culture and the era, the reality behind the symbol. In physical terms, a comet is not a messenger of destiny. It's an object following gravity, shedding material, reflecting sunlight. But in human terms, comets are a mirror. They reveal how the mind handles uncertainty. And even now, with science in hand, comets can still feel like omens. Only the omen is simpler and more honest. The universe is active. Chapter 9: Did impacts shape climate and history? Here we enter a careful zone, the boundary between what we know strongly and what we suspect, debate, and investigate. Some researchers have proposed that certain climate shifts or regional disruptions could be linked to impact events or airbursts. In a few cases, there is evidence for impacts in specific time windows. In others, the evidence is incomplete, and scientists argue vigorously, as they should. The Younger Dryas debate, presented carefully. One example often discussed is a period of sudden cooling near the end of the last ice age, sometimes linked by hypotheses to a cosmic event. Some studies suggest impact markers. Other studies question those markers or interpret them differently. The debate continues. This is a good moment to appreciate how science behaves when it's healthy. It argues with data. It tests claims. It updates conclusions when evidence improves. So when you hear this impact changed history, the calm approach is sometimes yes, clearly, sometimes maybe, sometimes no, and the story is more complicated. Reality is often complicated, but that's not a weakness. It's a sign the universe is real. Chapter 10. How often do impacts happen? People often ask for a schedule, as if the sky keeps appointments. But nature doesn't work like a calendar. Still, we can speak in general patterns. Small events are common. Tiny meteoroids enter the atmosphere constantly. Many burn up unseen over oceans and empty land. The planet quietly catches cosmic dust all the time. Medium events are rare but real. City-shaking airbursts like Chelyabinsk are uncommon, but not once in a billion years uncommon. Over long stretches of time, they are part of Earth's experience. Giant impacts are very rare. Crater-forming, extinction-level impacts are extremely rare on human timescales. But over geological time, tens of millions of years, they are not impossible. Earth has been hit before, and it will be hit again, eventually. The comforting part is this: we are not helpless spectators anymore. Chapter 11. Watching the Sky. Planetary Defense. Calmly explained. For the first time in Earth's history, a species is actively searching for dangerous objects before they arrive. This is sometimes called planetary defense. It doesn't mean militarizing space. It means building catalogs, tracking orbits, refining predictions, and planning options. How we reduce risk. Surveys find objects and measure their paths. Observatories refine the data over months and years. Risk assessments estimate close approaches. In rare cases, missions can test techniques to slightly change an asteroid's trajectory long before impact would be possible. The key idea is gentle and powerful. A tiny change early can become a big miss later. And even when the subject sounds dramatic, the process is patient. It's mostly math, telescopes, and careful planning. The universe throws stones sometimes. We are learning how to look up and step aside. Chapter 12. The difference between asteroids and comets. In practical terms, asteroids and comets can both cross Earth's path, but they tend to behave differently. Asteroids, the rocky neighbors. Asteroids are often rock and metal bodies, many originating from the inner solar system's debris fields. Their orbits can be tracked and refined, and many are found through systematic surveys. Comets, the fast, cold visitors. Comets may arrive from far away on long, stretched-out orbits. Some can appear with less warning, moving quickly and changing brightness as they approach the sunday. In risk terms, comets can be trickier because they're less predictable in discovery timelines. But it's important to keep scale in mind. Most comets are not threats. Most are distant, harmless, and breathtaking. Chapter 13. the gentle kind of impact, meteor showers. Let's return to the softer side of the story. Meteor showers happen when Earth passes through debris left behind by a comet or sometimes an asteroid. The particles are often tiny. They burn up high in the atmosphere, producing brief streaks of light. A night ritual older than writing. For thousands of years, humans have looked up and watched these lights. Different cultures gave them different meanings, but the experience is the same. A dark sky, a quiet breath, a small flash, a reminder that you are on a moving world. Meteor showers are a kind of cosmic weather report. We are traveling through a solar system that has dust in its lanes, and the dust turns into beauty. Chapter 14, What happens at the moment of impact? For the rare cases when a large object reaches the ground, the physics becomes intense, but we can describe it simply. The world compresses. At very high speed, the ground behaves almost like a fluid. Rock shatters, melts, and flows. Energy is released faster than the environment can absorb normally. Craters and shocked minerals. Large impacts excavate craters, throwing material outward and upward. Minerals can form distinctive patterns under extreme pressure geological fingerprints that help scientists confirm impact sites millions of years later. The aftermath matters most. The initial blast is local to regional. The global consequences, if any, come from what's lifted into the atmosphere and how it changes sunlight, temperature, and rainfall patterns. So an impact is not just an explosion. It's a climate event waiting to unfold. Chapter 15, Earth's Scar Collection. Earth has many impact craters, though not all are easy to see. Wind, water, tectonic activity, and vegetation erase scars over time. Oceans cover most of the planet. Old craters can be buried under sediment. In other words, Earth is good at forgetting. But with satellites, geology, and careful study, we keep finding evidence of ancient impacts, some small, some large. The planet wears its history like a faint set of rings in a tree trunk. Not obvious at first glance, but unmistakable when you know where to look. Chapter 16, The Psychological Impact. Why these stories stick. There's a reason meteor stories feel different from many other natural hazards. Earthquakes come from below. Storms form within the atmosphere. Volcanoes rise from the planet's own heat. But meteors and comets come from elsewhere. They remind us that Earth is not sealed off. We are not living under a dome. We are part of a larger environment. That can feel unsettling or strangely comforting, because it means our world is connected to something vast. And in that vastness, patterns exist. Orbits exist. Predictability exists. Understanding exists. Fear comes from the unknown. Knowledge turns fear into proportion, and proportion is calming. Chapter 17, A Soft Timeline of Notable Events. Let's lay a few stories gently on a line, like stones placed beside a trail. Ancient past, the Chicxulub impact, a large asteroid impact strongly linked to a major mass extinction, reshaping life's trajectory. 1908, Tunguska. A major airburst flattening forest over a vast area with no confirmed large crater, showing the power of atmospheric explosions. 2013, Chelyabinsk. A smaller but still significant airburst over a populated region, injuring many due to shattered glass, showing modern vulnerability and modern documentation. Ongoing, meteorite falls. Frequent small events delivering space rocks to Earth, helping science understand the early solar system. These are not signs. They are chapters in the natural history of a planet traveling through space. Chapter 18. The Comforting Reality. Here is the calm truth. Most of the time, Earth is safe. The atmosphere does its work quietly and constantly. The sky burns up countless small visitors without anyone ever noticing. The oceans and forests and cities carry on, and at the same time, the universe remains what it is, dynamic, full of moving pieces, governed by consistent physical laws. The best kind of comfort is the kind that doesn't pretend danger doesn't exist, but places it in context and shows you the tools of understanding. We watch the sky, we map the orbits, we learn from impacts preserved in stone. We improve our warning systems, and we keep doing what humans do best when we're at our best. We turn mystery into knowledge, closing, falling asleep under a moving universe. As this story settles, imagine the Earth from far above, a blue sphere turning slowly, clouds curling over oceans, night sweeping across continents like a soft veil. Now imagine the space around it, not empty, but lightly populated with ancient debris, dust streams, quiet rocks, distant comets in long, cold orbits. Most of those travelers will never touch us. Some will burn into brief streaks of light, harmless and beautiful. A few, over long stretches of time, will leave marks that become geology and history and lessons. And beneath all of it, you are here, breathing in a room, listening to a voice, safe in a world that has weather, oceans, mountains, and an atmosphere that shields you while you rest. The sky moves, the planet turns, and you can let your thoughts drift like a slow comet tail, quiet, pale, and fading gently into sleep.